Morning, everybody. All right, we got 12 people already. That was fast. Cool. So I want to talk a little bit about the exit slips because we're gonna experiment with that today. Good morning. Yeah. So there's now a portion on the website. Oh, look at that! We're going all the way down to 7. We had 12. I don't know what happened to everyone. Oh, back up to 10. Okay, whatever. Yeah, we have exit slips now on the website. I'm gonna wait for a few more people to show up because I want as many people to be aware of the exit slips as possible. Okay, so today, in terms of like the mathematical content that we're going to be covering, we're going to talk about systems of linear equations a little bit more. We're going to get a little more practice in, and coming up, we are going to have an assignment. So the assignment is going to cover several topics. We've been covering quite a bit of ground lately. I think that we should take a moment to be proud of ourselves. So we've done a lot of stuff since the beginning of March. So some of the things that we've done is even since the last assignment. The last assignment was mostly on trinomials and factoring things and simplifying rational expressions. Since then, we've looked at graphing linear equations, looking at different forms of linear equations. We've looked at the distance between points, how to calculate the midpoint. We've been looking at systems of linear equations and all the different ways you can solve them. So we've covered quite a bit of ground. For some reason... Okay, so YouTube is telling me that the bit rate is really low, which probably means that it doesn't look super high def. So I'm gonna quickly change that. Give me 1 second. How do I do that? So the bit rate right now is 2500. What are they recommending? 4500. So I'll do 5000. I've got a good internet connection, so let's do 5,000, and hopefully that just works instantly. Look at that. Hopefully now you can see all the little imperfections on my face and all that good stuff. Probably couldn't notice anything as it is because it's just a gray background. So, but as soon as I started writing, it probably would have looked bad. I'm not sure why that would have changed. I was kind of messing around in my my streaming software this weekend, so maybe that was it. Okay, where did you guys go? There you are. Okay, yeah, it looks the same. The bit rate is how many megabits per second your stream is. Now it's saying something really silly. It's saying the stream's current bit rate, which is 5,300 kilobits per second, is lower than the recommended bit rate. And the recommended bit rate is 4,500. So I think it's just a fake message now. I have fixed it. Yeah, the bit rate is just pretty much like how much data you're sending per second, like how many bits per second you're sending over the internet to YouTube. And you can set that in the streaming software that I use. I use OBS, Open Broadcast Software. Yeah, like I said, you probably couldn't tell the difference between the low quality and high quality, and that's just because we haven't written anything. If I'd started to draw, then the quality probably would have started to look pretty shoddy. Yeah, so I guess that's what we're gonna do today. Is we're gonna look at more systems of linear equations and get prepared for another assignment. I want to. Now that I think we've got about 26 people, which is about as much as we get these days, I want to show you about our exit slips. So if you go to our website and and just right on the home page, you can see that there is a button for an exit slip. So if you click on this exit slip here, then it will take you to this little page. It's like a Google form, just like any of our assignments lately. You have to punch in your email address. Please use your Winnipeg School Division email address. Your first name and last name, so enter that in. Excuse me. And then tell me which class you're in. So there's 2 grade 9 sections, you know that. And then there is the submission. So that would be like the answer to the question of the day. So as far as I can tell, right now I'm thinking we'll just do 1 question, just to keep it simple. If I find that that's not challenging enough, or if it's not really working out very well, then we might up that to, you know, maybe 2 questions or 3 questions. But I think that for now 1 question will be fine. So so I haven't given you the question yet. We'll do that in the live stream. So the thing that you might notice on this exit slip is that it's very generic. There's no question on it. I'm going to be asking the questions in the live stream. Now, there's no date on here, and that's because with Google Forms, it automatically records the date and time, so you can immediately see the date and time. So I don't need you to tell me what the date or time is. What I do need you to do is just to give me the solution. Now, I'm well aware that not everybody attends the live stream, and that some people prefer to watch the video after the fact, and I'm okay with that. That's perfectly fine by me. If you can't get here on time, that's all right. I would much prefer you to be here live. That way you can ask questions, and there's some back and forth. It's not just one way. Do we use our school email or a personal email? I said earlier, I think that I prefer you to use your school email. Yeah. Anyway, yeah. So if you do watch the live stream a little bit later, that's okay. I still need you to do the exit slip. Now, I will only accept the exit slip submission that day, so it's got to be before midnight. Okay. So if you do not enter the exit slip before midnight, then I'm gonna count that as nothing. So it's only going to be, I'm only counting it for that day. And the reason I'm doing that is not to be mean or cruel or strict. The reason for that is because the last thing I want is for my students to sort of have all these videos sort of pile up on one another. Okay. So yeah, it may be piling up on one another. So if you have like 5 videos, that's 5 hours of material. I don't want you to do that. So it is to encourage you to watch 1 video a day, or at least 1 video every day that we have class. So yes, you can think of it like attendance. Yeah, so that's kind of the purpose of this, is to have some kind of accountability for attending either the live stream or at least watching the video the same day that it comes out. So just to be clear, we have class every even school day. So this week that will be Monday, Wednesday, Friday. Next week it'll be Tuesday, Thursday. So this I'm hoping will encourage you to partake in the classes regularly. So and you know, if you miss a class, it's not the end of the world. It's just like school. Sometimes you're sick. Sometimes there's another obligation. I get it. That's fine. But at least this way, I'm able to determine how many students I'm reaching, how many students are attending class, and that's important information for me. Okay, so that's that. If you have any questions about what if you get it wrong? No, if you get it wrong, you're still present. That's a good question. but at the same time, if you're just kind of like punching in, a bunch of gobbledygook like ASDF, XY, blah blah blah, then we might have to have a little conversation. But yeah, if you get it wrong, that does not mean that you're absent. So the idea here is kind of twofold. For one, I want to see who is present, and for two, I kind of want to see if you're engaging with the questions, right? Because if I give you a question and then you just put sort of a silly answer for your submission, well then we might have to have a conversation, and I might send you an email or something and ask you about how you're doing and that sort of thing. So yeah, and if you have any other questions about it, then please don't hesitate to ask. Okay, so let's talk some more about systems of linear equations. And what I thought we would do today is just do, I'm going to do a couple of examples. And then what we'll do is I'll kind of put an example on the screen here, and I'll get you to do it. And we'll go over the solution together. And then the third time, I'm going to get you to do it by yourself, and you'll submit that solution to... you would submit that solution to the exit slip. Okay, so let's start off with a question on substitution. So we're going to use the substitution method. So I'll write question 1. Use the substitution method. Substitution method. So we're going to use the substitution method to solve. Solve what? Let's do this one here. Yeah, we'll do kind of like a medium difficulty because we have a little bit of experience with this. So we don't have to start off right on the easy end, but I don't want to go off on the deep end either. So we'll do this one here. So this is going to be minus 7x plus y equals 8. Oh, plus y equals 8, plus y equals 8. And the other equation is negative 6x minus y equals negative 8. Okay, so we're going to use the substitution method to solve this system of linear equations. So what we're going to do is we're going to end up, so basically the idea of substitution here is that we want to solve for one variable. Okay, so taking one of the equations, we're going to solve for one variable, and then we'll plug that solution that we get for that one variable into that variable in the other equation. So I'm going to call this equation 1, I'm going to call this equation 2, and we're going to take a look at equation 1, and we're going to solve for y. I'm going to solve for y in equation 1. Why am I solving for y? Well, because I see a plus y right here. So y is pretty much like, it's almost all on its own. It's almost all just solved by itself. All I have to do is bring the 7x, or the negative 7x rather, to the other side, make it positive, and then we've solved for y. So let's do that. I'm going to say, okay, so I'm just going to write the whole thing out, negative 7x plus y equals 8, and I'm going to add 7x to both sides, so that gives me y equals 8 plus 7x. Okay, now I'm going to take this solution and plug it in to equation 2. All right, so equation 2 looks like negative 6x minus y equals negative 8. And we are going to take, and I'll put this in a different color. How about, why don't we make this green? So this is going to be the color green. And I'm going to take this y and plug it into this negative y. So I'm going to put brackets around it just to make sure that we completely understand what's going on. So I've got negative 6x minus, and y, we said that y is equal to 8 plus 7x. So if y is equal to 8 plus 7x, then negative y is equal to negative 8 plus 7x. Okay, and I'm putting brackets around it because we've got this minus sign here. Okay, it's not just going to be it's not going to be like just the first term. It's not, we can't just write negative 8 plus 7x, right? That's not what it's equal to. The whole thing is negative, so it's negative 8 minus 7x. That's why I put them in brackets, because we're going to have to distribute this negative sign throughout those brackets because they're both negative now, because all of y is negative. It's not just one of the terms. It's not just one of the terms that's negative. It's the whole thing that's negative. So carrying on, we have to complete writing the equation. So this is equal to negative 8. Okay, and I just copied that from here. So I really just wrote the same equation down, but I replaced y with what we solved for y in the other equation. Okay, so now I'm going to go ahead and distribute that negative sign. We've got negative 6x minus 8 minus 7x equals negative 8. And although that looks like a bit of a handful, you can tell now this is a single equation and there's a single variable. So we're good. We're good. So let's go ahead and solve this. So let's see here. So I've got negative 7x, negative 6x minus 7x. That's negative 13x minus 8 equals minus 8. Okay, getting somewhere. So I'm going to add 8 to both sides. So that means that negative 13x is equal to 0, right? I've added both 8 to both sides. And okay, so if negative 13 times x is equal to 0, that must mean that x is equal to 0. The only way you can get 0 from multiplying a number is to get 0, right? So, I mean, if we wanted to, what we could do is we could divide both sides by negative 13. 0 divided by negative 13 is 0. So x is equal to 0. So what that means is that now we can go back. We can choose either equation. We can choose equation 1 or equation 2. Okay, and that's the whole point of this, is that it doesn't matter which equation that we want to plug this value of x equals 0 into. I'm going to choose equation 1 just because. Okay, so using equation 1, okay, I'm going to rewrite equation 1. Equation 1 was negative 7x plus y equals 8. And I'm going to plug in x equals 0 here. So I've solved that x is equal to 0. Now we need to figure out what y is. Well, negative 7 times 0 plus y equals 8. So negative 7 times 0 is 0. I'm just going to cross that out. And it turns out that y is equal to 8. So the solution is, well, the ordered pair x comma y, we call that an ordered pair, We call it an ordered pair because it's a pair of numbers and order matters. We have the x value before the y value. So the ordered pair x comma y is equal to 0 comma 8 because x is equal to 0 and y is equal to 8. So that's our solution. Now, if you were punching this into the exit slip, or if there was an assignment, you could just write this portion right here. That would be perfectly fine. Be perfectly fine. Okay, so that's the first question. We'll do another question right away. I think. Does anyone have any? Okay, what are the letters yet? Brayer, Macintosh. Didn't we already do this last class? Yeah, we're going over it. Yeah, we're doing a bit of a review. I want to make sure everyone is kind of warmed up before I send you off to the races. So let's try another example. Let's do something maybe a little more challenging. Okay, so let's do this question. So we are going to solve. Come on, there we go. We're going to solve, so this is question 2. So I'm going to do these 2 questions myself, and then I'm going to give you a question, and then we'll solve it together. And then so that would be question 3 we'll do together, and question 4 is going to be all you. Okay, it's going to be all you. So question 2 is solve by elimination. So we're going to solve this system. So I've got 7 over 6 times x plus 5 over 6 y, no, plus 5 over 6 equals negative y, okay, and that's one equation. The other one is 0 equals 4y plus 10x plus 30. Yikes, look at that equation. Holy smokes. So this is a bit of a mess of a system of linear equations. So I'm going to call this equation 1. I'm going to call this equation 2. Okay? Now, the thing about elimination is that you're allowed to manipulate the equations before you get started. And that's actually true of any system, right? Like if we wanted to, we could have manipulated either of these equations, and in fact we did in this first step here. We did manipulate the equation. We solved for y. We brought the x to the other side. So we're going to manipulate these equations before we start solving for them. Okay, so I'm going to solve this one by elimination. So I'm gonna start sort of getting rid of some of the fractions. I don't like working with fractions. If there's any time that you can avoid working with fractions, then avoid working with fractions, because it's so often it's the cause of many mistakes, because everyone always forgets how to add fractions and things like that. So what we're going to do is we are going to eliminate the fractions. So I'm going to get rid of the fractions, in equation 1, okay? And the way I'm going to do that is I'm going to multiply both sides of the equation by 6, okay? So I'm going to rewrite equation 1, okay? I'm going to multiply both sides of the equation by 6. So I've got 7 over 6x plus 5 over 6 equals negative y. And why am I choosing 6? Well, because the denominator is 6. And if I multiply both sides of the equation by 6, then I completely eliminate all of the fractions. And I really want to do that because I don't want to have to work with fractions. So if I multiply both sides by 6, so I've got 6 times that and 6 times that, I'm manipulating the equation, but I haven't sort of broken any rules. I've multiplied both sides of the equation by 6, so that's fine. So that gives me 7x plus 5 equals negative 6y. That's so much easier to work with. And I'm going to manipulate it a little bit more. What I'm going to do is I'm going to put all the x's and y's on the same side, and I'm going to put all of the rest on the other. So this is actually going to be 7x plus 6y equals negative 5. Okay? So this is my new equation 1. So this is equation 1 kind of improved. So I haven't changed anything about the equation other than how it looks. Let's do something similar to equation 2. So here's equation 2. And really all I'm going to do is I'm just going to move everything to one side, and then we'll see what it looks like. So I have, let me just zoom out a wee bit. There we go. And oops, there we go. Okay, what am I trying to do here? Okay, let's start by writing the equation down. So I've got 0 equals 4y plus 10x plus 30. Okay, that's a good start. And what I'm going to do is I'm going to just move all of, I'm going to keep all of this to one side. I'm going to have, let's write 10x, 10x plus 4y. And if I bring the 30 to the other side, it becomes negative. And you'll know I did sort of two things here. I sort of changed the position, the left-hand side and the right-hand side. It's okay. I mean, if I have x equals 5, that's the same thing as 5 equals x, right? That they mean the same thing. So I moved the 4y and the 10x to the other side, but I kept them positive, which made the 30 become negative. So if you have any questions about how that works, let me know in the chat. Okay. Okay, yeah, sorry, I kind of lost track of the chat here. Okay. So this one is not for the exit slip. Yeah, this question, yeah, we're gonna do the last one on the exit slip. Yeah, okay, question 4 is gonna be the exit slip. So this is question 2. We're gonna do question 3 sort of together. I'm gonna give it to you. You're gonna work on it for a few minutes, and then I'm gonna show you the solution. And then question 4 will be your exit slip. And what if you have 2 different denominators? Yeah, you could either multiply it twice, or you would do the lowest common denominator. The lowest common denominator would certainly be the most efficient way to do it. What do you mean by no common denominator? I think he means no, comma, you use the common denominator. Yeah, exactly. So if you had 2 denominators like 2 and 3, then yeah, you would do 6. Or if you had like 2 denominators like 4 and 6, the lowest common multiple of those 2 numbers is 12, right? So it's not like you just multiply them together. Okay. Anyways, sorry. I should have my eye on the chat. I changed windows so I could see the list of questions that I made earlier today. Anyway, so these are our 2 equations now. I've got 10x plus 10x plus 4y equals negative 30. I've got 7x plus 6y equals negative 5. Okay, so now we're getting somewhere. I'm gonna write them one on top of the other. I'm gonna write them one on top of another, and then we'll take a look at some of the things we can do. So I'm gonna write 1 and 2. I like writing them one on top of the other because then I can compare them very easily. So I've got 7x plus 6y equals negative 5, and I've got 10x plus 4y equals negative 30. Okay, so now what we're going to do is we're going to choose a variable. And if you want, you can choose them randomly. You can choose the variable randomly, or you can try to find a variable, like you can be strategic about this. And I'm going to try to be strategic about this. I'm going to try to find 2 variables whose coefficients, that's the number in the front. I'm going to find 2 variables whose coefficients have some common factors. Okay, and I see that 6 and 4 have a common factor. Now this isn't required, but it just makes your work a little bit nicer. So if you don't really understand like the strategy, that's okay. Don't stress out about it. Just the point is that your work will be a little bit nicer and it'll just be a little bit easier. Your numbers will remain smaller if you choose 2 numbers who have some common factors. Okay. And again, that's not always true. So the thing about these types of questions is that experience really helps. It really helps if you do a lot of these questions because there's so many different things. And if I just told you all of the different things that you should do in every single situation, we'd be here for like 6 years because it takes too long for me to just tell you. Whereas if you just do the problems, then you can kind of see and develop your own strategies. There's so many strategies on this. There are entire courses, such as this course right here. This is one of my favorite classes. I think I told you last time I used to teach this class. This isn't the book that I used to teach. I think I brought that book to our old classroom at school. Oh, here's my cat. She wants to say hi to everyone. Oh, and hi Goose, say hi to everyone. Yeah, so there's so much to say about this. We're just like touching the tip of the iceberg. Like, and even to say that, it's like we're touching like the tip of the iceberg. Like there's so much that can be said about systems of linear equations. Yeah. So just try these questions for yourself because there's so many different strategies that you can develop and you can get really good at solving these really fast. So anyway, I'm going to choose the 6 and 4. And what I want to do is I want to think of what is the least common multiple of 6 and 4. Okay, Goose, I need that pencil. You can't just eat it. So what is the least common multiple of 6 and 4? Well, that is 12, right? Because 12 is a multiple of 6, it's a multiple of 4, and there's no smaller number that makes that true. So what I'm going to do is I'm going to say, okay, what do I need to multiply 6 by to get 12? It's a lot like adding fractions here. So it's a lot like adding fractions. So I have to say, okay, what do I have to multiply 6 by to get 12? Well, that's 2. So I'm going to multiply both sides of this equation by 2. So I'm going to multiply this by 2. I'm going to multiply that by 2. Now the other equation, this equation, I'm going to say, okay, what do I have to multiply 4 by? What do I multiply 4 by to get 12? Well, I multiply by 3. So there's 3. Multiply that by 3. Okay. And there we go. So now I'm going to actually write this out again. So here's equation 1. Here's equation 2. And now I do this multiplication. So 2 times 7 is 14. So I've got 14x. I've got 12y. And this is equal to negative 10 because negative 5 times 2 is negative 10. And 3 times 10 is 30. I've got 30x. 3 times 4 is 12. It better be 12 because that's what I wanted. And negative 30 times 3 is negative 90. Okay, and now you'll notice that I've manipulated both of these equations so that I've got a 12y in both of them. And now I can eliminate them. Okay, so I can eliminate the 12y. So I'm going to do that. What I'm going to do is I'm going to subtract this equation from the other one. So I'm going to subtract equation 2 from equation 1, and what I'm going to get is the following. Well, 14x minus 30x, that's going to be negative 16x. 12y minus 12y is 0, so I've got plus 0. And that's all equal to, well, negative 10 minus negative 90. That's the same thing as negative 10 plus 90. That's going to be 80. So I've got 16x equals 80. And there you go. There I've gone ahead and I've eliminated the y's. And this portion right here is what we're talking about when we refer to elimination. I wish you could see Goose right now. She's being unbelievably cute, but also a little bit annoying. She's kind of lying right on my iPad, and now she's trying to attack my hand. Goose, I gotta work. I've gotta work. Okay, so that means that x is equal to 5. Okay, so this is what we call elimination because we eliminated the y's. And you can tell we had to sort of massage the system a little bit first, right? It didn't work right out the gate. We had to sort of first of all, I had to set it up so that I had all the variables on one side of the equation, right? I also had to get rid of the fractions because the fractions, you can imagine this would have been much harder to do with fractions. Oh, did I make a mistake? Oh, yes, sorry. This is negative 16x, pardon me, which means that x is negative 5. Makes me so happy when students correct me, and I'm not joking. When students correct me, it tells me that people are paying attention. So that's very good. Okay, so x is equal to negative 5. That's great. Now what is y equal to? So y is equal to, well, let's see if one of these equations has y all by itself. So let's use this original equation, and because y is already by itself, so we don't really have to solve for anything. So if I have, and I'll just sort of, you know what, I'll do this the long way. You know what, let's actually do this properly. I'm trying to make some shortcuts, but I think it would be better if we just did this the long way. Okay, so let's choose equation 1, and I've got 14x plus 12y equals negative 10. And we've said that x is equal to negative 5. So I've got 14 times negative 5 is equal to, plus 12y equals negative 10. Okay. Okay, and so negative 14 times 5, that's a negative 70, plus 12y is equal to negative 10. Okay, so I'm going to add 70 to both sides, so that gives me 60 over here. I've got 12y equals 60, so y is equal to 5. So y is equal to positive 5. Can't we plug x into the original equation? Yes, absolutely. We can choose any of these equations. That's the whole point of this, is that we could choose the original equation 1, which is what I wanted to do originally, but then I thought, well, we're dealing with fractions and stuff, so it might be kind of annoying. We could plug it into this equation, this one, this one, this one. Any of these would be fine. Any of those equations would be fine. Okay. So our final answer is that x comma y, the ordered pair xy, is equal to -5 comma +5. Okay. All right. So we're almost at the point where we're ready to do one together. Well, actually, we are at the point where we're going to do one together. And let's say I'm going to give you. Well, class ends in 5 minutes, so I'm going to give you 5 minutes to do it. So I'll do. We'll do one with substitution. Okay, so this is question number 3. Solve using substitution. And the equation that we're going to do is, let's do this one. 2x minus 5y. 2x minus 5y equals -7. And -6x minus y equals -4. Equals -4. Okay, so I'm gonna give you 5 minutes to do that one, and I'm just gonna give you the solution because I don't think we have time to do like a full explanation. Oh, if you hit Control W, you will close your window. Oldest trick in the book. Kind of like how you can open up like a cheat menu in a video game by hitting Alt F4. Okay, so we're gonna solve for this using substitution. So go, you got 5 minutes, and I will tell you this solution in about 5 minutes. I'm gonna go. Well, I guess I'll just hang out here. No, this is not the question. So I'm going to give you this solution. Okay? This is not for exit slip. This is for you. I want you to practice this. This is like your test run. You can try this one for free. And the next one will be for the exit slip. Yeah. I don't know if you can hear Goose, but she's purring pretty loud. And then she's moving the iPad. Goose. Oh my gosh. That's her moving it. Goose, you're crazy. Crazy cat. Oh yeah, she's vibrating. Okay. It's been about 5 minutes. I'm just going to give you the solution to this one. So the solution to this one is x comma y is equal to 0 comma 4. Okay? 0 comma 4. Oh, sorry. Oh, shoot. You know what? I miswrote this one. So you know what? I don't actually have the solution. Man, that's a very silly mistake. Oh, jeez. Okay, so I'm going to quickly solve this one. Oh, goose. Ay. It's very hard to work with a cat right beside you. But it's also kind of the best. So I have nothing to complain about. So I chose two different equations from different systems. So I'm going to have to solve this one really quick because I made a mistake. So I'm going to quickly solve for x. So this is equation 1, this is equation 2. We're going to have to go over. Sorry guys, I just realized this now that this isn't actually a question that I had prepared earlier. This is two equations from separate systems to make their own system. So I'm gonna solve for 1. So I'm gonna say that x is equal to that would be 5 over 2y plus 7 over 2, and then I will plug that into the other equation. So in equation 2, I've got negative 6 times 5 over 2y plus 7 over 2 minus y equals negative 4. So I'm going really quickly because I just want to give you the solution so we can move on. And so this gives me, that would be negative 15y plus, minus 21, minus y equals negative 4. Okay, that looks good. And I've got negative 16y is equal to, I'll add that. That gives me 17. Yeah, 17. Okay, and that means that y is equal to 17 over 16. Yuck! What a gross. I'm sorry about this question, guys. This is not a nice question. This was a mistake. I apologize about that. Yeah, not a very fair question. Kind of a gross question because there's lots of fractions. But I guess at the end of the day, it is good to be able to work with fractions. So now we'll plug this into equation 2, and I'm going to get that negative 6x minus 17 over 16, because that's what y is, equals negative 4. And I will add 17 over 16 to both sides. So this gives me negative 6x is equal to 17 over 16 minus 16 over 16, or sorry, 16, oh yuck, 16 times 4 is 64. Okay, so negative 6x is equal to, oh brother, 17 minus 64 minus 17 is, well I gotta carry that 7, 4, it's 47 over 16, and then divide both sides by 6. So x is equal to, 16 times 6, that's 36. 6, 9, so that's 96. So I've got negative 47 over 96. Yuck. What a gross system. So this one, I don't know if you actually got this. X, Y. I'm surprised no one complained. This is going to be negative 47 over 96, comma, 17 over 16. Okay, so awfully sorry about that. Not the question that I intended on giving you. Yeah, so, yeah, you got something different. So, 0.4, Well, this one's about 0.4, and that one's a little over 7.8. I'm not sure about 7.8. It's, you know what, let's forget about this one. I'm just going to give you the question for the exit slip, and we'll call it a day. So you have until the end of the day to finish this one out. So this is question number 4. Okay, and let's do this one here. Okay, so this one here will be, so we're going to solve by substitution. Substitution. Okay, and the system is x plus 4y equals 16, and negative 8x plus 8y is equal to negative 8. Okay, so that's what we're going to solve, and that's your exit slip. So this is the exit slip. And your solution should look something like, like open bracket, some kind of number, comma, another number, and then close bracket. So that's what your solution should look like. So one number followed by another. And just as a hint, both of these, these are whole numbers. Okay, so don't write any decimals. If you're doing decimals or square roots or something, you've made a mistake. Just give me some whole numbers. Okay, so that's the form that I want. Just open bracket, number, comma, number, close bracket. Okay, so I'm not going to write this on the website. So if you want, what you can do is you can pause the video, or if you forget to pause it, you can always go back on YouTube and rewind, so you can take a look at this question. Let me just double check that I wrote the question down wrong, because or correctly, because I did write the last one down wrong. So negative 8x plus 8y equals negative 8. And I'll make this look a little bit nicer. Negative 8x, oops, come on. Negative 8x plus 8y. Okay, yeah, that looks nice. So that's your exit slip for today. You have until the end of the day to do it. I would recommend doing it right now. It should probably take about 3 minutes. So so get her done. If you have any questions about the exit slip, don't hesitate to ask, although I do have another class coming up very shortly, so I may not be able to answer your question right away. But yeah, and just to be clear, the purpose of these exit slips is mostly just about attendance. So if you're feeling overwhelmed by the exit slips, let me know and we'll see what we can do. But yeah, it shouldn't take too long. In fact, if you started now, I wouldn't be surprised if some of you might even be finished, right? So so yeah, hit pause and finish it off, and I will see you guys, or I guess talk to you guys, and you guys will see me on Wednesday. Okay, bye bye.